Now students, continue the 16 group elements and then sulfur dioxide formula SO2. Preparation of the sulfur dioxide from the air, heating of sulfur in the presence of air or oxygen, dioxygen to give sulfur dioxide. S plus O2, SO2. And also the sulfur dioxide also prepared in the laboratory in the presence of sulfide. SO3 minus sulfide it is. Sulfide is reacts with the sulfuric acid H2SO4 2 for water and sulfur dioxide. 2 hydrogens plus 1 oxygen to form water and remaining S plus O2 sulfur dioxide. Preparation of sulfuric acid from sulfide SO3 converts to SO2. In industrial method, preparation of sulfur dioxide from iron pyrites Fe2 is reacted with oxygen. It is called the roasting process. Heating of the ore in the presence of oxygen is called roasting. Oxidation to gives Fe2O3 plus 8SO2. Preparation of sulfuric acid from roasting of FeS2. These are three methods to prepare sulfur dioxide. And properties of sulfur dioxide. Sulfur dioxide is the colorless gas. Sulfur dioxide SO2 is the colorless gas with the pungent smell like ammonia and soluble in water. Sulfur dioxide characteristics reactions. Sulfur dioxide reacts with the water to form sulfurous acid. And it has one low pair of electrons. It is structure sulfurous acid H2SO3. Next state, it has only the oxo acid having lone pair of electrons. One mark they will ask what happens when the sulfur dioxide reacts with the water. Sulfurous acid H2SO3. What happens when sulfur dioxide reacts with the base? NaOH is the base. Sulfur dioxide reacts with the sodium hydroxide base to form sodium sulfide Na2SO3. Sodium sulfide. Again sodium sulfide reacts with the sulfur dioxide second time to give sodium hydrogen sulfide. Sodium hydrogen sulfide. It is one of the uses of sulfur dioxide to prepare sodium bisulfide. What happens when a chlorine reacts with the chlorine gas reacts with the sulfur dioxide? When chlorine gas reacts with the Cl2S, the sulfur dioxide gas in the presence of charcoal, here charcoal acts as a catalyst. Then converts into SO2Cl2. It is called sulfural chloride. This is important. I ask you for 1 mark. What happens when chlorine gas reacts with the sulfur dioxide to form SO2Cl2? Let's write the name and formula. Sulfur dioxide reacts with the oxygen in the presence of catalyst vanadium pentoxide V2O5 to form sulfur trioxide SO2 converts into SO3. Instead in the preparation SO3 sulfide to prepare sulfur dioxide. Now sulfur dioxide into sulfide. It is also useful for the preparation of sulfuric acid in the presence of in the next class. Prepare the sulfuric acid from contact process. In that we are using these two reactions. Sulfur converts to sulfur dioxide and sulfide to sulfur dioxide to sulfide. Structure of sulfur dioxide SO2. It is similar to the carbon dioxide structure CO2, angular in shape geometry. It has one bond pair and one lone pair to form layers to the canonical forms of resonance structures of sulfur dioxide. And uses of sulfur dioxide. Sulfur dioxide is used in the refining of petroleum and sugar, and it is used in the bleaching of wool, silk, and used as a disinfectant and used as a preservative. And also it is sulfur dioxide is also used as a used in the manufacturing of H2SO4, sulfuric acid, sodium bisulfate, calcium bisulfate, and liquid sulfur dioxide, liquid SO2 is used as a solvent because organic molecules, organic materials are soluble in organic solvents like liquid sulfur dioxide. So that sulfur dioxide, liquid sulfur dioxide is used as a solvent. And the next concept is oxo acids of sulfur. Sulfur containing oxygen. Here see sulfur, 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 sulfur containing oxygens. O, oxygen, oxygen, oxygen. Oxo acids of sulfurs. Here 1, 2, 3, 4. 4 types of oxo acids for the sulfur. Number 1, sulfurous acid formula H2SO3. It is only the acid, oxo acids of sulfur containing lone pair of electrons. Sulfurous acid formula H2SO3. H2SO3. It is a very familiar one. H2SO4, sulfuric acid. H2SO3 plus 1, H2SO4. Two double bonds, two single bonds, and two oxygen double bond, and two OH bond. How many OH are present in sulfuric acid? Two OH. Peroxo disulfuric acid. Peroxo means O2. Peroxo disulfuric. Here one sulfuric, here one sulfuric. Peroxo disulfuric acid. Formula H2SO4. H2 here means one hydrogen, 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 H2. S2, OH. 1, 2, 3, 4, 5, 6, 7, 8. H2, OH. Name is peroxo disulfuric acid. And last one of oxo acids of sulfur is pyrosulfuric acid. Pyrosulfuric acid. Here formula H2SO7. One oxygen is less than that of pyroxo disulfuric acid. Here one oxygen in the middle, here two oxygens. So that pyro less. One oxygen H2 hydrogen H2 same, but oxygens are 7. H2SO7 name pyrosulfuric acid. Next one, sulfuric acid. Formula H2SO4. Preparation of sulfuric acid or manufacturing of sulfuric acid by contact process is one of the very important function for polymers. Preparation of sulfuric acid or manufacturing of sulfuric acid H2SO4 from by the contact process. Step 1 is follows. Production of sulfuric acid. Production of sulfuric acid. Passing of heating of air, sulfur in the presence of air to give sulfur dioxide, and passing of oxygen, roasting the heated of the ore, that is iron pyrites in the presence of oxygen to form sulfur dioxide. This is step 1. It is a flow chart for the manufacturing of sulfuric acid by contact process. Passing air to the sulfur powder, then it is burns, sulfur converts into sulfur reacts with oxygen, converts into sulfur to sulfur dioxide, converts into the steam sulfur dioxide. This is the reaction when sulfur reacts with oxygen. Otherwise, ore is heated with in the presence of oxygen, converts into sulfur dioxide. Second step, after the sulfur dioxide, oxidation of sulfur dioxide by providing the steam. Oxidation provide oxygen to the sulfur dioxide, then sulfur dioxide converts into the trioxide. See, it is the sulfur dioxide. Now sulfur dioxide is oxidized by adding oxygen in the presence of V2O5, vanadium pentoxide. Here vanadium pentoxide is a catalyst used in the preparation of contact process at low temperature and high pressure. Low temperature and high pressure, accordingly it gives more products because the number of moles of the reactants is more than that of the number of moles of the products. But here high temperature and low pressure is maintained. At that condition, sulfur dioxide converts into trioxide. Delta enthalpy change in enthalpy is equal to minus 198.6 kilojoule per mole. It is takes place in the step 1 to 3. Here dust particles gets precipitated and removed, and it is a heating process, exothermic, and the cooler means provide water and the supply overflow, and to convert into, after cooling the steam, sulfur dioxide converts into sulfur trioxide. Washing and cooling the tower, and again it is passed through the drying tower. In the next steps, sulfur trioxide, absorption of sulfur trioxide by reacts with sulfuric acid H2SO4. By adding H2SO4 to the sulfur trioxide converts into fuming sulfuric acid. Fuming sulfuric acid, or it is called pyrosulfuric acid, commonly called odium. 3 names. One is pyrosulfuric acid, another fuming sulfuric acid, another odium. Formula H2SO7. How it is? Odium is formed. Sulfuric acid is added to the sulfur trioxide. Absorption of sulfur trioxide. After absorption, sulfur trioxide converts into fuming sulfuric acid. H2SO7. In that, there is arsenic impurities. The arsenic impurities are identified and removed. Then it is passed to the preheater. After heating, it is converts into the vanadium pentoxide catalyst. It increases the rate of reaction and then transferred into the another chamber. It is containing 98% of sulfuric acid. 98% of sulfuric acid means it is concentrated. Then it is collected separately. And then after fuming sulfuric acid is converts into fuming sulfuric acid H2SO7 converts into H2SO4 by adding the water. It's called dilution. By adding water is called dilution. Water is added to the pyrosulfuric acid or fuming sulfuric acid, converted to 98% of sulfuric acid H2SO4. This is the process of preparation of sulfuric acid from by contact process. 3 marks. Diagram is not necessary. These the steps, 4 steps and reactions are important. Physical properties of sulfuric acid H2SO4. H2SO4 it is already observed in first UC laboratory. It is a colorless liquid and dense oily liquid. And specific gravity is 1.8 at room temperature, and the acid freezes at 283 Kelvin temperature and boils at 611 Kelvin temperature. And dilution of sulfuric acid in the laboratory, you must take precautions. Acid, concentrated acid is adding to the water, by constant stirring, because it produces heat. Otherwise, if you add water to the acid, the sulfuric acid. In aqueous solution, sulfuric acid ionizes to give H plus and HSO4 minus ions. 2 times H2SO4 reacts with the water to form this 3O plus HSO4 minus. And another time HSO4 minus reacts with the water to form H3O plus hydrogen ion plus sulfate. Here it forms hydrogen sulfate, here it forms sulfate. But these two having different, very different dissociation constant values Ka1, Ka2. It has very large value, it has less value. Which one is having the higher dissociation constant value? It is the more stronger. So that first one, sulfuric acid reacts with water to give H3O plus and HSO4 minus. It has a more dissociation constant value. The greater the value of dissociation constant, Ka, stronger is the acid. So that the larger the value of Ka indicates that sulfuric acid is largely dissociates into H plus and HSO4 minus. It forms 2 types of acids: normal salts and acid salts. Normal salts like sodium sulfate, copper sulfate. Na plus HSO4 2 minus, Cu2 plus SO4 2 minus. In acid salts, NaHSO4, Na plus HSO4 minus. Acid salts. Because of this, sulfuric acid has low volatility, so that it forms low volatile acids from their corresponding salts. For example, it is a salt MX. Here M is a metal, X is any halides or nitrates. Metal halides or metal nitrates react with the sulfuric acids to form corresponding hydrogen halides plus metal sulfates, whether may be normal salt or acid salt. Like sulfuric acid is a strong dehydrating agent. What is meant by dehydrating? Removal of water. Removal of water. For example, like carbohydrates, this is sucrose or any carbohydrate. Carbohydrates react with the concentrated sulfuric acid to give water. Liberation of water means water lost. Here remaining charge, only carbon is remains, so that it is a strong dehydrating agent, removes water. What happens when sulfuric acid is filled with the metals and non-metals and compounds? It is act like a concentrated sulfuric acid is act like a moderately strong oxidizing agent. Say, for example, it is a copper metal reacts with the sulfuric acid, concentrated sulfuric acid. Copper converts into copper sulfate. Copper sulfate displacement reaction. Here, remaining hydrogen plus oxygen to form water, and sulfate converts into the SO2. One SO2. One SO2, one is SO4. So, it indicates that it is an oxidizing agent, because here metal is don't having any oxygens. It oxidizes by sulfuric acid, so converts into copper to copper sulfate. Like that, sulfur, yes, only sulfur gets converted to sulfur dioxide by reacting with the concentrated sulfuric acid. So it is oxidizes the sulfur to sulfur dioxide. And sulfuric acid, HSO4, concentrated sulfuric acid, oxidizes the carbon to carbon dioxide, so that it is a strong oxidizing agent. Uses of sulfuric acid, it has many industrial chemical applications. It forms, it used to prepare hundreds of compounds, and it has many applications. So sulfuric acid is called king of chemicals. And sulfuric acid is used in the manufacturing of fertilizers, petroleum refining, and used as a because electrophiling and cleaning purpose. And sulfuric acid used in the lead storage and in our laboratory.